Welcome to lesson number 12, Learn C Programming on the Raspberry Pi. Okay, we're starting to get somewhere now. Last day we worked on 3 LEDs. We did some work on using binary numbers. And so let's just review that before we continue on with lesson 12. First we'll have to go over to the Raspberry Pi. And we'll start Genie. And we'll look at the 2 examples we did last day, or last lesson. So one example we did was just turning on the lights one at a time and then turning them off. So, well, let's try this again just to verify that it still works. This was part of a lesson 11. So we have the 2 programs here, binary and LEDS. So let's try LEDS first. LEDs. So what should happen when we run this is we're going to do this 5 times because our for loop here, and it ends down here. So all of these lines in here are going to be executed 5 times. Okay, so when I is 0, we are going to turn on the red light, wait for 1 second, turn on the green light, wait for 1 second, turn on the blue light, wait for 1 second, turn on the red light, wait for 1 second, turn on the green, or turn off, sorry, the green light, wait for 1 second, turn off the blue light. So these are the 3 where we turn them off. We send a low signal, which is ground, 0 volts. And here we turn them on with a high signal, which is 3.3 volts. So if I run this, let's see if it still works. There's the red, green, blue, then off, off, off. So you can see it right here. And it does it 5 times, so that still works quite well. And while that's going, just take a look up here. I put down the functions we've been using so far, the C library functions, the math library functions, and the wiring pi library functions. And last day we also learned how to count in binary. So if you don't know how to count in binary, then it's probably a good idea to learn how to do that, because a lot of programming involves working in binary. Okay, let's try the next program now. We did last day was the binary program. And here, basically we had the 3 lights count from 0 to 7. So if you look here, with 0, all 3 lights are off. With a 1, we have the blue light is on. So this is a 1. And with a 2, the green light is on. With a 3, the green and blue lights are on. See a 3, if you look at a 3 here, it has 2 1s. Okay, so we're using here a switch statement to select one of these 8 cases. The cases go from 0 to 7, so we have 8 cases. So in our for loop, I is equal to 0, our switch statement will select case 0. when I is equal to a 1, then our switch statement will select case number 1. And that's how we get these lights toggling as a binary counter. So let's try that out. We'll just run it. So there's 1, 2, 3, 4, 5, 6, 7, and then we turn them all off after that. So you can see the last, after the for loop is finished, the last thing we do is we turn all of the lights off. Okay, so it's making some sense. Let's close these guys now, and we'll start a fresh program for lesson 12. But we'll still use those 3 LEDs. We'll just write a little different program now. So let's start with and I also want to, I guess I shouldn't have closed those guys. Let me reopen this one here, just so I can cut and paste some information here. I'll take that and I will just paste it here. Okay. What I'd like to do here is I'd like to prompt the user to type in a color, red, green, or blue, and then depending on what they enter, I will light up the corresponding LED. So here we go. Printf So the first printf here, I will just prompt them. I'll prompt the user to enter a color, red, green, or blue. And then what I want to do is I want to read their answer in. But in order to read their answer in, I'm going to need a variable. Up to now, all we used were integers, floats, and single characters. Well, now I'll introduce you to an array of characters. So instead of just having one character, like for example X, I want to have a whole bunch of them kind of in a string or in an array. So what I'm going to do is I will just say character. I could call it anything I want, but let's say I'll call it color. So if I just say this, character color, I only have one character. Could be an R, G, or a B for red, green, or blue. But that's not good enough. I want them to type in the whole word red, green, or blue. Okay? So we'll try it this way first, and just to see how it works. So I'll say here, I'll say if, well, first we have to do the scan, SCANF, so I have to read in %C, comma, ampersand, color. Okay. So remember that when I read something in from the keyboard, I'm reading in one character, and I'm putting it into this variable color, but it has to know where to put it in the RAM, in the memory. So I put this ampersand in front to say the address of color. So store your character in the address specified by color. So color here is some kind of an address. So I read that in. Then I have to decide, did I read in an R, G, or B? So I'll say if color is equal to an R, okay, then I want to turn on the red light. So I'll say digital write, and I will say red underscore LED underscore GPIO comma high. Okay, let me save this guy as let's see, I'll have to save it. File, save as. I want to put it into directory lesson 12. So in lesson 12, I'm going to call this, let's call this COLOUR colors.c. So if the person types in an R, you notice the double equal sign here is used for comparison. I'm checking to see if color is equal to a single character. Well, now we have to check if it's green. So I do this. I can check if it's a green. If you typed in a G, then I can turn on the green light. Okay. And finally, if you typed in blue or B, then I'll turn on the blue LED. And that's it. That's my whole program. TUR return 0, and that's it. So you notice in my include statements here, I'm including wiring pi because I'm using these functions, but I have not initialized anything in wiring pi yet, so I better add that in, and I'll just copy it from my LEDs. Just copy these lines here. Okay. Why don't I just put a space down here like this. Make it more readable with a blank line in there. So I'll save this. Now if you look what it does, I have 3 defines up here. These are just replacements basically. Wherever it sees red LED GPIO, the C compiler will just put in 25. So you can just imagine that there's a 25 here. Okay. And I'm also using stdio header so that I have the proper definitions for print and scan. Well, now I can compile the program, so I can build it. Say build and see what happens. And it worked correctly. You remember from last day, I added in this -L wiring pi to include the wiring pi library in our GCC compilation. Okay. So it worked okay. Let me try running it. I'll go to lesson 12, and there I have it. /color. So I'll run it now, and it says enter a color, red, green, or blue. Well, if I put something in that's not an R, G, or B, then nothing should happen. So I type in a U, and nothing happened. None of the lights came on. But if I try run it again, and this time I put in an R, then the red light comes on. And you notice even when the program is finished, the red light stays on. Because what happened is I did a digital write here, and it sent a high voltage to that GPIO pin. So it turned the light on, and the light's on until I turn it off. Okay. So perhaps what I should do is at the end, I should just reset all of these guys back to lows, and I can do that when I use the other program I had right here. I can just set them all back to a low. Of course, I'll take out the delay. And what I'll do is I'll add in one delay at the end of the ifs. Well, actually it might be a better, well, no, it's okay. I can put a delay in here. Let's say delay for 2 seconds. But you notice the delay for 2 seconds will happen even if I don't select any color at all. So let's try this. Save it, build again, and I can run it again. And this time I'll select green, which is the middle lamp. Of course, you notice the red was already on. And so now it went off because at the end of my program I turned them all off. Let me just try the green again. G just turns that on for 2 seconds, then they all go off. Okay, let's try the blue. Blue, and the blue goes on. Okay, well this is great, but you notice it has a problem. If I type in, for example, uppercase R does not work, because uppercase R is different from lowercase r, and all I'm doing is I'm checking if it's a lowercase r. So I could have put in here an OR color is equal to an uppercase r. So I could have put these two vertical bars signify an OR Boolean operation. Basically, I'm checking to see if color is equal to a lowercase r or color is equal to an uppercase R. Then I want to turn the red light on. So I could have added that in to make it a little more user friendly. And I'll build it again. And now I can run it. And this time I can put in a capital R, turns the red light on for 2 seconds, or I could use a lowercase r, turns the light on for 2 seconds. Okay. But let's try to make this a little more complicated. Suppose I wanted to type in the whole word. So instead of just typing in one character, I want to type in the word red or the word green. How would I do that? Well, instead of having one character for color, I'd have to have room in the memory for at least, like green is the longest word, 1, 2, 3, 4, 5. I'd need to have room for at least 5 characters. So to play it safe, well, maybe not so safe, but I'm going to put in 10 characters. I'm going to assign or allocate 10 characters for the variable color. So color now is no longer a single character. Color now is an array of characters, or you could say a string of characters. And by typing in this statement here, I'm basically telling the computer or the compiler that I want to save 10 memory locations for this variable color. Okay. Well, now, because I'm using an array here, I have to change my scan. My scan is no longer scanning a single character. My scan now is going to scan a string. So I got to put an S in here. And the second change I have to do is that because I'm using an array here, I no longer need to have this ampersand. I know it's almost a little counterintuitive, but but in C, the name of the array is actually the address of the array. So I don't have to put in the ampersand. Well, now, instead of doing these kinds of checks like this, I have to use a function from the C library to check to see if what the person typed in is the string read. So I'll have to use a function called string compare. If string compare color red is equal to 0. So, well, let's take a look at this. This is a C standard library function, string compare. It's going to compare what I typed in from the keyboard with this string read. If they compare, this function is going to return a 0. So I'm going to check for a return value of a 0. If they don't compare, in other words, if there's no comparison here, this will not be a 0. Okay, sounds good. So let's change this other one now. I'll change this one if compare check the green, and now I'll check the last one will be, I'll check the blue. Okay, so it's very close to what I had before when I was just putting in one letter, one character, but now the person is going to be typing in the whole word, either red, green, or blue, and it will go into this array. I've already allocated space, I've left room for it. So this is only good for colors that are about 10 characters long. About, I say, because it's not exactly correct, but we'll get to that later. Okay. So now I can save this guy here. I think maybe what I'll save it as colors 1. Let's see, save as, and I'll save it as colors -1. It's version 1 of colors. Save. So I have the old one someplace. I don't need this here anymore. Okay. So let's try compiling it, see if it works. I'll try building it. And you notice it says here I have no declaration for string compare. There's no prototype for it. So I have to include another header file. So even though this function string compare is part of the C library, it has its own header file right here, string.h. So save that, build it. Let's see if this compiles correctly or not. Yes, it did. So let me add down here from the C library. I want to add in strcmp, since we just learned a new C library function. So it compiled okay, so let's try running it. Colors 1, and now I can type in RED, and it should turn the red light on, as it does for 2 seconds, and then it turns them all off. So I could try the other ones. Blue, and it turns the blue on for 2 seconds, then turns it off. Well, of course, you can still see there's problems with this, because, for example, I'm comparing all lowercase, red, green, and blue. If the person types in, like for example, if he types in capital RED like this, it doesn't work. No lights come on. Okay, so we're going to have to fix this, but I think we'll save that for the next lesson. Okay, so just quickly let's recap what we did here. Everything is the same as we did before. We defined our 3 GPIO pin numbers. We initialized the wiring pi library, and we set the 3 GPIOs to output mode. But what's different here is that instead of creating a single character, we created an array of characters. Sometimes you could call it a string of characters if you like. But I've allocated in memory this variable color has a maximum of 10 characters, 10 bytes. Well, then we go down and we say, okay, type in a color, and now our scan is different. We no longer are scanning for a single character, we're scanning for a string. So it's %s is our format. And since we're using an array, we don't have to put the ampersand in. Okay, so I could just put in a comment here. So color is the beginning address of the array. So I don't have to put the ampersand in because it's already an address. And then of course, we do 3 if statements to check, did he type in red, green, or blue? You notice something else that's interesting here is in the if statement, since I'm only using one statement in the if, I don't need to put parentheses or braces. But I think a lot of people do put the braces there, like this. It's probably good practice to always use braces in an if statement. So if I had something else in here, for example, something else like delay to have another pause there, inside the if I have 2 statements now. So now I absolutely, positively need to have these braces. So the rule is, if you only have one statement, then you don't need the braces. They're optional. How do you know you have one statement? Well, you have one semicolon. Semicolon is used to terminate a statement in C. Okay, so we'll just save this guy, and I think that's probably enough for lesson number 12, but I think for homework you should probably try hacking this, see if you can figure out how to see if the person can type in uppercase or lowercase for these values and it should still work. And next day I'll show you the answer to that. Okay, so let's close some of this stuff up. And I think this is the end of lesson number 12, and we'll see you next day for lesson number 13.